हेलो स्टूडेंट्स, एक क्वेश्चन देखते हैं। इस क्वेश्चन में देखिए क्या है, अ स्फेरिकल पोर्शन हैज बीन रिमूव्ड फ्रॉम अ सॉलिड स्फीयर हैविंग अ चार्ज डिस्ट्रीब्यूशन यूनिफॉर्मली इन इट्स वॉल्यूम एज सोन इन फिगर। द इलेक्ट्रिक फील्ड इनसाइड द एम्प्टीड स्पेस। देखिए राइट, तो इसके इनसाइड में इलेक्ट्रिक फील्ड निकालना है। तो लेट अस टेक अज्यूम राइट, आई एम अज्यूमिंग हियर द सेंटर ऑफ बिगर वन a sphere is here and the center of a smaller sphere is here. Okay, so I am taking any random point. Let us take any random point here, and at this point I am calling it P or something. So I am trying to find what is the electric field at point P. Okay, so what I will do here, right, this is cavity, so I will fill it first. Right, I am assuming that this is right, this cavity is filled with the charge of the same density, right? Whatever charge density is here, with the same charge density I have filled this cavity also. First I have done this. Let us call this one as part 1 and this I am calling as part 2. Okay, okay, so now I can say the electric field at point P. So electric field at P will be equal to electric field due to the whole sphere, that is 1 plus 2, right, minus electric field due to this part 2, right, part 2. Then if you will subtract from the whole, right, 1 plus 2 is the whole sphere, right, and if you subtract from this, then you will get the electric field due to part 1 only, right, that is P. So we will get the electric field at P due to 1. You can say like you will get the electric field I am talking about at P, at point P I am taking. So due to this we will get the electric field due to 1, that is 1 is this part. Okay, and this only I need to find out. Okay, so let us see, right, so let us put the values here. So 1 plus 2 is the entire sphere, right, and the point P is inside the sphere. So the electric field will be what, 4 by 3 pi k rho, and let us take, right, this is the center. So let us take this vector I am taking as x vector. Okay, so this will be your x vector minus electric field due to part 2, that is this inner one. So once again you will get 4 by 3 pi k, and the density is same for both, so here also rho. And let us take the position vector of point P with respect to the center of this smaller cavity. Let us take this is y vector, so I will just take it with some different one. So let us take this one is y vector. Okay, this a smaller one is y vector. Okay, so this is your y vector. Okay, now see, right, this everything will come outside. So right, 4 by 3 pi k rho, this will come outside, and this will come x vector minus y vector. So 4 by 3 pi k rho. Now see, right, x vector minus, right, y vector will become this vector. Let us draw it here with some different angle. Right, if you take this line and let us call this vector is r vector, so I can easily from this triangle I can say, right, r vector plus y, right, in this triangle, if you take this triangle y p y x and r x and y, if you take this triangle, so in this triangle I can easily say r vector plus of y vector must be equal to x vector. I can easily see r vector y vector in the same direction, that will be equal to x vector. So x minus y, so I can say here r vector is equal to x vector minus of y vector. Let us call this is equation 2. So from the equation 2, right, from sorry, this is equation 1 I will call, no problem. Okay, because no other equation is there. Okay, so let us call this is equation 1. Okay, so from the equation 1 I can say x vector minus y vector is equal to r vector, so I can put it here, so this will become r vector. Okay, so let us see, r vector is nothing but the position vector of center of the cavity with respect to the center of bigger sphere. Okay, so now I can put the value here, so 4 by 3 pi, the value of k already I know, 1 upon 4 pi e naught, right, and this becomes rho r vector. So 4 pi will get cancelled out, and you will get here rho upon 3 e naught r vector. So this you are getting the electric field at any general point inside the cavity. Okay, so you can see easily from here the electric field is constant vector. So see, right, A option. So now I can see the options. Okay, so let us see the option A. 0 everywhere, this is wrong. Right, non-zero and uniform, this is correct, because the electric field inside is coming uniform. R vector is constant because R vector is the position vector of center of cavity with respect to the center of bigger sphere. So non-zero and uniform. Okay, so this will be the answer. Okay students, I hope you understood this question.